Here we have a pre-calculus problem. Okay, let's go to the question. List the intervals of continuity for the function f of x equals to x squared positive x negative 2 over x squared positive 5x positive 6. Okay, so whenever we have a rational function like this, rational function means the function must contain variable in denominator. In this function, we have variable in denominator, so it's a rational function. And if I wanna find intervals of continuity for a rational function, what I need to do is first I have to find the values of x which make the denominator 0. So because in any fraction, if the denominator is 0, the value of the function, the value of the fraction is considered to be undefined. So now to find the intervals of continuity for this rational function, so my first work is to find the values of x which make the denominator 0. So for that, I have to equate the denominator, that is x squared positive 5x positive 6 to 0 and solve for x. Okay, now it's a quadratic equation, and if I solve this quadratic equation, I'll be getting two values for x. Okay, now I think we can solve this quadratic equation by factoring. So for that, what I need to do is I have to consider the coefficient of x square over here. We don't find any number in front of x square, so I have to assume there is the coefficient of x square is 1. So in that case, we have to multiply this constant of positive 6 by this coefficient of x square. Then I'm getting 1 times positive 6 is positive 6. Okay, now I have to get two factors for this positive 6, so that the product of the two factors equals to positive 6, and the sum of the two factors must be equal to the middle term, which is the coefficient of x, that is positive 5. I think a positive 2 and positive 3 will work. So when I multiply positive 2 and positive 3, I'm getting positive 6. When I add them, I'm getting positive 5, which is the coefficient of x. So further, what I need to do is I have to divide both these factors, positive 2 and positive 3, by the coefficient of x square, that is 1. So even when I divide this positive 2 by 1, it's still positive 2, and when I divide this positive 3 by 1, it's still positive 3. So now I can get the two values of x so by changing the signs of these two factors. So here the first factor is positive 2. To get the first value, I have to change this positive sign as negative. Then the first value of x is negative 2. And to get the second value of x, I have to change the sign of the second factor. Then it will become negative 3. Okay, so these two values of x, that is negative 2 and negative 3, will make this denominator 0. And you can verify, that is, you can plug in x equals to negative 2 over here. So when I do so, what will happen? This negative 2 whole square will become positive 4. And when I plug in negative 2 for this x, positive 5 negative 2 will become negative 10, positive 6. So 6 positive 4, 10, 10 negative 10, 0. So the value negative 2 for x makes the denominator 0. And the same thing we can verify for negative 3 for x, that is, we can plug in negative 3 for x over here and we can check it. So definitely it will make the denominator 0. So these two values cannot be considered as the domain of this function, because these two values, negative 2 and negative 3, makes f of x undefined. So whenever I want to find the intervals of continuity, I have to remove the values of x which makes the function undefined. Okay, now what I need to do is I have to mark these two values on the real number line. So let me mark it. So negative 2 and negative 3, the smaller one is negative 3, and the negative 2 is greater than negative 3. So, and on the right side extreme we have positive infinity, and the left extreme we have negative infinity. So when I list the intervals of continuity for the given function, I cannot consider these two values, because these two values makes f of x undefined. That means f of x, the given function, is not continuous at x is equal to negative 3 and x equals to negative 2. So now when I mark these two values, when I'm at negative 2 and negative 3 on the number line, I get three intervals. The first interval is negative infinity comma negative 3, and the second interval is negative 3 comma negative 2, and the third interval is negative 2 comma positive infinity. And I just use a parenthesis. Parenthesis means I cannot consider the boundary values. So I can consider all the values between this and this, but I cannot consider this negative 3 because there is a parenthesis over here. So here, in case if I use the square bracket, we can include this negative 3 also. Boundary value can be included, but we cannot include this boundary value because at negative 3 the function is not continuous. That is, f of x is undefined. So we can consider all the values between negative infinity and negative 3. And here negative 3 comma negative 2 means we can consider all the values between negative 3 and negative 2. We cannot include negative 3 and negative 2 because of the parenthesis, open interval. And also here we can consider all the values between negative 2 and positive infinity, and we cannot include negative 2 or positive infinity. Okay, now we got the list of intervals of continuity for the function, and we find this list negative infinity comma negative 3, negative 3 comma negative 2, negative 2 comma positive infinity in option A. So the correct answer choice for this question is option A.